suggest that we start this this webinar. So thank you again for all for joining us this morning for the webinar on securing the software development cycle from risk analysis to vulnerability detection and software protection. So before we jump in, I would like to go through a couple of housekeeping topics. So today's webinar is being recorded. We will be able to share a link with you after the event is complete. Of course, we welcome you to revisit the content yourself and to share it with colleagues that might also be interested in this topic. Obviously, we also invite your comments and questions. Please look at the questions chat box on your screen. If you think of a question for the speakers at any point, just type it in there and we will take time at the end to answer as many questions as possible. If your question is for one specific topic or a speaker, please specify it at the beginning of your question. It will make our life more easier for answering with the right person. So that being said, let's jump in. So why are we here this morning? We are here to talk obviously about cybersecurity. Now, when we talk about cybersecurity, most people will think about things like access management, data integrity or protection, IT infrastructure protection against penetrations or malwares or ransomwares, or even encryption mechanisms. And clearly, these are most essential topics. But this morning, we would like to speak about something that is a bit less known, which is software application protection. All these IT security solutions that I mentioned, encryption, IT infra protection, access management, they all rely on software and software integrity. So if their software is not secured, or if their software beneath has vulnerabilities that can be exploited by attackers, all those tools are not useless, but the confidence in those tools is a bit more difficult to get. So our opinion is that the glue that holds everything together, the base for everything, is software and application. So we would like to speak this morning about what are the best ways to secure software and application, which is clearly the first line of defense, to secure against any kind of attacks or vulnerabilities or malicious usage of those softwares. As a last point, the Department of Homeland Security in the US mentioned that 90% of cyber attacks are exploiting some sort of issue, limitation, or vulnerability in deployed software. So again, the key question here that we are trying to answer is how to ensure the security of software assets, resources, and source code during the development cycle to ensure that those systems are as protected as possible. And to answer this question, I am joined this morning by Adrien Michon from Egerie and Thomas Reut from Quarkslab. Gentlemen, thank you very much for attending this webinar with me. And what I suggest now is to start with Egerie's presentation. So Adrien, I'm currently handing you the ball.
Thank you, Gabor. So hello, everybody. My name is Adrien Michon from Egerie Software, and I'm going to talk to you about risk anticipation today. So why is anticipation key? So it's more cost effective to anticipate attacks during implementation of the software or applications. Why? Because in case of cyber attacks, what is more costly to the company is first customer support, if their data have been linked or if they don't have access to your product or application. Implementing and deploying security patches, especially if you have to stop servers, stop productions, etc. The loss of strategic advantage due to theft of confidential data, for example, your RD document, etc. If your next year's product has been stolen, then you're going to lose some advantage. And of course, the impact on your reputation. It's been estimated in 2019 that the average cost of cybercrime for an organization is around $13 million. So let's say that it's like a good argument to anticipate the risk before they happen. And on the bright side also, it's been demonstrated that anticipating a risk and having a more secure product, more secure organization overall, can unlock future economic value because it's going to create trust between you and your customers. So how can you anticipate those risks? So to anticipate those risks, you need to identify first what needs to be protected. Then you identify the supporting assets that can be exploited to attack what you want to protect. You have to identify the risk scenarios that can happen. And of course, this is not a one-shot thing. You have to iterate the analysis throughout the lifetime of your system, depending on the threat landscape evolution, the new vulnerabilities that are going to appear, etc. So this has to be done from the beginning of your project till the end of your project. So this anticipation doesn't really need to be a hassle, especially if you use a risk management solution like Egerie Risk Manager, which is a solution that is multi-method, collaborative, which means you can engage third party to input their data and their information into your risk analysis. You can also use templates and everything that you created previously, all the data you have accumulated to make your new risk analysis, faster and more pertinent. And it can be used from a brand new project and also on an already existing system. So now I'm gonna quickly show you a quick demonstration of Egerie Risk Manager. So here I'm on the dashboard, which shows all the overall risk. I'm going to show you how it can be done through a new risk analysis for a new web application. So here I'm going to open a brand new template. So here, of course, the dashboard shows I have no risk because I haven't entered any data, but it already contains information that I've created, that I've accumulated over all analysis I've done on similar projects. So I'm going to use the guided mode to go over the different steps of my analysis. So the first step would be, of course, to describe what is going to be analyzed now, what kind of software, the different participants, etc. I'm going to pass quickly over that. We have a part, then after we're going to move on to the system classification, which is going to be used for example, for a brand new project to assess its criticality. So to assess how critical this software is and how like if I need to do an analysis, a thorough analysis or not. So this is a questionnaire that can be shared, of course, to third party, for example, to the project manager, etc. So it's going to be able to fill in a completely personalized questionnaire, and then you're going to be using those results for your analysis. And then we're going to start assessing, as I said previously, the different assets. So here we're going to find all the supporting assets, the most common. It's not exhaustive, of course, but the most common supporting assets for a web application. So you're going to find servers, data center, administrator, etc. With for each supporting assets, the vulnerabilities, the most common vulnerabilities for said assets. We're going to go then identify what needs to be protected. So my primary assets. So here I'm going to say that for my new web application, I'm going to have a customer database, for example, that needs to be protected. I'm going to link that database to my server. So it's going to be hosted on server. And I'm going to assess the security criteria of that primary asset. So I'm going to put a few assessments. And now I'm going to move on to my next step, which is identifying applicable standards. So it's possible in the analysis to enter several standards for one application and evaluate our compliance towards those standards. So here, for example, I'm going to have the ISO 27002. So I'm going to find all of the requirements, and I'll be able to check if I'm compliant or not with that standard. The next steps will be to identify the vulnerability that can affect the supporting assets that we've seen previously. So here I already have a catalog of known vulnerabilities that I can personalize. I can add the vulnerabilities that I've already found or listed in my previous analysis, etc. And they're going to be linked to my supporting assets. And to those vulnerabilities, we're going to link different security controls. So, for example, those are the controls that we usually add on our new applications, or measures that comes from security controls that comes from set standards that need to be applied, etc. So here we can see all the different security controls and their implementation status linked to vulnerabilities and supporting assets. And once we've entered all those data, or that we've gotten those data from a template that already existed, we're going to go to the risk identification, risk evaluation. So here I already have a list of risks that are part of this template that have been evaluated based on the primary asset, my customer database that I entered previously. And here I can see, sorted by the current and residual risk level, I can see which has the more critical risks. So I'm going to be able to take decisions now on which risk I need to reduce and what controls I need to apply. So here I can go and edit the status of this risk scenario, see all of the security controls that I can apply, and simulate the risk reduction. So I can go below my acceptability threshold. So here we go. I'm going to plan those two measures to have a risk level below 4. And those measures that I've planned are directly added to the treatment plan, and I can see my risk scenario, my risk level has already been reduced. Another tool that we have to make decisions on how to reduce the risk level is the decision air tool, where we can see all of the security controls and the percentage coverage of the overall risks on my system with the different risk scenarios linked to each security controls, and the cost and the number of man days to implement those security controls. So that's a good feature to make a ratio like based on the overall reduction of the risk and the cost of implementation. And to finish, we have, of course, as a risk analysis software, we have a reporting tool where we can, of course, edit a report in PDF in several formats for the management. That can be here. We can see that the risk that has been in initial critical level has been in residual risk, which is the risk with the planned measure taken into account, has been reduced. And we can see, of course, now on the dashboard that was previously empty, we can see our risk mapping now with the different risk levels and our risk distribution and the implementation controls, which is going to show the percentage, the implementation status for each control. So thank you for your attention. If you'd like to know more about our solution, I invite you to contact us at the email address contact@egerie.eu or on the phone number that shows on the screen. Thank you. I'm going to hand out the presentation to Gabor.
Thank you, Adrien. Let me take back the hand. Okay. So again, thank you, Adrien, for the presentation on the risk management. What I would like to talk about now is how to enforce cybersecurity during code development, and more specifically, how to make software robust against any kind of code vulnerability. But before I dive in, I would like to say just a couple of words about TrustInSoft. So here at TrustInSoft, we are a software publisher that exhaustively tests and mathematically guarantees that C and C++ code have no bugs or potential vulnerabilities left. And this really allows to maximize the safety and the security of critical but also less critical software. We recently raised a total sum of $7 million. So we secured the total funding with investors. We are totaling more than 30 years of academic research and development. Our softwares were initially used to secure nuclear reactors and airplanes, so really critical stuff. But now we are able to bring that kind of solution to less critical software and bringing the same kind of benefits and trust to other industries such as IoT, telco, or even the autonomous vehicles. We are 25 between France and the United States. We mainly work with huge industrial companies. Our clients include companies like Thales, like Safran, Airbus, Naval, ARM, even Sony. So we have a very wide landscape of clients, and of course, our solution was recognized by organizations such as the NIST in the United States or the RSA conference, and we even work with the Linux Foundation. So that being said, why are we doing what we are doing? Why is it? Why does it matter what we provide? It's critical because today software complexity is really increasing. It's drastically increasing. The software size and length is also exponentially increasing, and software becomes more and more difficult to comprehend as an overall picture. Also, software is used in more critical activities, in 5G, in AI, machine learning, industrial automation. We hand over more and more decision making to the software. And we also have a lot of legacy code. I mean, there have been softwares for the last 40 years that need to coexist with all the newly written software without creating regression. And of course, I'm not going to teach you anything here, but there are increasing amounts of attacks and cyber crimes that cost trillions of dollars, and most of them are exploiting existing 0 days and vulnerabilities in the code. So it's very important, according to us, to analyze, to verify, and to make sure that there are no vulnerabilities or bugs or issues left in all those codes deployed on all these industries. What we are really focusing on is identifying and correcting what's called undefined behaviors. Undefined behaviors, they can really, they are, things that can exist in the source code, small issues that can really be exploited by attackers. For example, if you are a little bit specialized in programming, buffer overflows, reading from uninitialized variables, pointer overflows, violating type rules, all these things are very difficult to catch and usually are not catched by the compilers. So even if the program is executing, even if the software is working in most of the scenarios, if there are undefined behaviors left, we can never be sure. We can never give a 100% trust to the software, because who knows what can happen if specific scenarios occur. So we really focus at TrustInSoft, we really focus on identifying and correcting the undefined behaviors that can be left in critical software. Just to give you a couple of examples of what's happening if you leave things like undefined behaviors in critical and important code. I'm sure that most of you already heard about Heartbleed some years ago, which caused a huge issue, huge hassle in the OpenSSL cryptographic library. Everybody was talking about it. Was a huge security breach, and the main cause was in the code, in the OpenSSL's library source code. Another example, which is much more recent, it's the Ripple 20. Which was a series of 19 0-day vulnerabilities left in the source code of the TCP/IP library of a specific company that was deployed on hundreds of millions of IoT devices. And all these vulnerabilities, most of them, I mean, can, for example, allow remote code execution. So again, huge security issue that has been caused by vulnerabilities and bugs left in the source code of the cracked TCP/IP library. So that's why we are really focusing on, let's say, eradicating the undefined behaviors, because it can lead to huge consequences like Heartbleed or Ripple 20. So okay, we understand that we need to catch all those undefined behaviors, but how do we do it? Is for example testing enough? A lot of companies are doing testing today, which is great. It's the best way to start testing and verifying your source code. But the question is it enough to catch all the undefined behaviors? Is it enough to have full confidence at the end of the day that there is nothing left in the source code? It's a tricky question, because most of the tests are done with discrete values. So at the end of the day, even if it's working for 1,000 values, maybe it's not going to work for 1,000 and first other values. So it's not enough to test with discrete values. It's a great start, but it's not enough to give confidence. Also, a lot of companies consider that test efficiency is computed on the number of lines covered instead of values and states, which is another limitation. Maybe during the tests, not all the execution paths were tested, who knows. And also there are many coding standards on syntax and structure, which are again a great start, but they are not offering a full confidence at the end that there are no undefined behaviors left. So what is the solution? What solution do we propose? Entering TrustInSoft Analyzer. So what we propose at TrustInSoft is a very advanced application security testing tool that is able to mathematically guarantee that there are no vulnerabilities or undefined behaviors left in C, C++ source code of any kind of program. We are doing three main families of testing and verification. The first one, the first step, let's say the easy step that can be very quickly used by any developer, is to supercharge the existing unit tests. This will give the ability to the developer to detect any undefined behaviors without false positives, without false negatives in their unit tests. So it's very powerful, because even when you're trying to test your software with unit tests, we are able to help you out with giving you the right tool to ensure that you have no undefined behaviors left in your source code. It's very powerful. The second step is that we generalize the existing tests to have a very exhaustive analysis at the end of the day. And this will catch exhaustively all the undefined behaviors in all the program. And the key word here is exhaustivity. Exhaustivity means that we are analyzing all the values possible, all the execution paths. So it's like a very powerful X-ray or IRM scanner that is able to go through 100% of the code and identify any kind of undefined behaviors. And the last step, which is the most, let's say, most powerful as such, is checking the functional implementation to ensure that the software or the program behaves in compliance with the specifications. So we are checking that in any scenario, the behavior of the program matches the specifications. This is a very powerful feature that is mainly used in the aircrafts and autonomous vehicles, because it really identifies, it really ensures that all scenarios, really 100% of possible scenarios and outcomes are covered. So nothing undefined or nothing that was not forecasted can happen. It's really exhaustive and very powerful. So how are we doing this? We are doing this by really analyzing the semantics of the program. If I can make a comparison, when you cook, you follow a recipe. And this is, by the way, very important, and it's the best practice. Always start with the recipe to be sure that you can achieve what you want to do. It's the base. But if, as a cook, you also need to taste the preparation, because following a recipe does not give you any guarantee. It's a great start, but it does not give you any guarantee that the taste is going to be excellent or as you expected. So the only way to ensure that the taste is good is to taste your preparation. And for this, you can follow any kind of recipe. The only way to ensure this is to taste it yourself. And this is basically what we are doing. We are tasting the program. We are analyzing the semantics, the meaning of the program in a mathematical context. So it's quite complex, but the key message here is that it's great to start with the syntax, it's great to start with the coding rules and to code well, but it does not protect you against vulnerabilities at the end of the day. You need to taste, you need to analyze the program's semantics to be sure that there are no bugs or 0 days left. And this is what we are doing at TrustInSoft. So just to sum up, we are bringing the best of different analysis tools. We are bringing features from static analyzers, dynamic analyzers, sanitizer, fuzzers, and so on. And we are putting them in a context of formal methods. So basically, mathematical construction and mathematical execution of the code, and we apply that to existing customer test suites. And at the end of the day, we are able to prove the absence of undefined behaviors, and we are able to maximize the safety security of your code. So the key word here is trust and proven absence, because it's a very powerful technique. It means that at the end of the day, as a developer, you can be sure that there are no undefined behaviors left. You can sleep well. You know your program is always going to work, whatever the inputs, whatever the execution path, whatever the scenarios. So yeah, we bring a lot of different features with our tool. We bring an interactive graphical user interface that allows developers to explore all the variable values and to visualize basically how the code works in detail. We are bringing a very rigorous mathematical modeling and understanding of the source code. We can integrate with existing fuzzers to test large and input values. Very important, we are compatible with all target platforms, or almost all target platforms, so either ARM, x86, and so on. And of course, we are providing interfaces with continuous integration or continuous development tool. So TrustInSoft Analyzer is a tool for developers and Q&A teams to really ensure that at the end of the day, there are no bugs left in the code. If you want to learn a little bit more about how our tool works, we did recently an analysis of the popular open source network packet analyzing tool Wireshark. So we analyzed a part of the code because it's open source, and we were able to find a lot of issues going from small to important. What I suggest is that at the end you click on the link and you watch the video, and you will have a very good overview of how easily we can achieve this kind of analysis, and how it ensures that at the end of the day, the Wireshark tool, for example, is much more robust once the bugs have been corrected. So that concludes my presentation. Now, if Thomas, if you are ready, I will hand you the ball for the last presentation of the webinar.
Okay, Gabon. So, anybody can see my screen?
Yes.
And you don't see the GoToWebinar screen?
Thomas, we see your screen, application shielding, Quarkslab. We are ready.
Okay. So good morning, everybody. I'm very pleased to be your host for the more or less next 15 minutes. My name is Thomas Roach, and I work as a pre-sales engineer for Quarkslab. I hope you enjoyed what you saw and heard so far, so make yourself comfortable with a refill of coffee or any beverage of your choice, and feel free during this talk to ask your question in the chat. If you are too shy or think your timing is wrong, don't worry, we have everything planned, and you'll have a second chance at the end of the talk. Now that we have proceeded to the usual reminders, let's begin and dive with me in the topic of application shielding. So, as Adrien and Gabor showed us just before, adopting the best practices and auditing your code is crucial to make your application secure. But sometimes it's not enough. At Quarkslab, our engineers are used to perform security tests for their audit missions. In accordance with defined and specific methodologies, they deliver certification or assess the security level of different devices or applications. And what we learned on multiple occasions is that you cannot rely only on methodical approaches when it comes to security. Let me be clear on this. I don't say get rid of the methods or automating testing tools. It's useless. I just say it's not enough. For example, there are some design flaws that won't be detected by automatic code testing. You can find a lot of examples if you Google it, like Checkmate and so on. Another example, and that I know a bit more of, it's because people at Quarkslab were involved in it, is the 2019 Intercesty Challenge organized by the ANSI, and that was about the audit of an open source and open hardware project wiki. You can find the article on the STIC website and parallel work on the Quarkslab blog, which is called How a Security Anomaly Was Accidentally Found in EL6 Plus Java Card. Yeah, I emphasize accidentally because let's say that the human approach is not completely overwhelmed by the machine approach yet. But this is another story, and we don't have too much time this morning to speak about it. So let's continue and talk about some example of risk you will have to face. So one obvious example of this is the theft of intellectual property. It's a common place to say that applications are the fruit of investment in money, time, and efforts. But I think it is worth to remind it, as we saw a lot of examples every day that seems to prove that some are not convinced by this. In order to prove my point, let's see a famous example that is a little bit old, but you all agree that people who undergo this kind of mishap are not very eager to communicate on it. So this example is a story of Sega versus Electronic Arts. The action takes place back in the 90s. At this time, Sega charged $8 to $10 for every cartridge produced on the Sega Genesis. For example, NBA Jam sold 1.93 million copies, and EA wasn't so keen to pay at least 15.4 million in licensing fees alone. For a reminder, I'm talking about dollars in the 90s, so it's not the same as today. So what did Electronic Arts do? They are a team of reverse engineers, and they reverse the console to avoid paying those fees, and they succeed. As you are a very attentive and curious audience, I'm sure you are wondering how they achieved to break the protections. I'm afraid the answer won't be as epic as you would have loved it to be, because there was no protection against reverse engineering at this time for Sega. EA proceeded with what we call a clean room reverse engineering and two isolated teams. So how it works. Two teams were set up. One examined the actual hardware by taking it apart, while the other team documented what was done by writing manuals and creating development tools for use. Neither team had contact with the other, and all communication was done through lawyers to ensure that no protected information was exchanged. Software engineers avoid directly examining the software that is emulated through the use of test programs and publish specifications. Through this method, the engineers are prevented from using any part of the emulated code in the software they were creating. Electronic Arts' use of the clean room method was a direct contrast to what Atari had done to Nintendo a few years back, and that was called the dirty room engineering. The fun part of this, if I can say so, is that Sega quickly agreed to a compromise with EA because they were afraid for once to lose a lot of money, and secondly, that EA sold the knowledge to other developers. If so, Sega would have ceased being a console maker a lot sooner. For the ones who were old enough to know the Sega Genesis console and EA games, the reason why EA cartridges had the little yellow tab in the upper corner and were a little bit longer than other Genesis games was due to the reverse engineering work. And more recently, and in the same area of video games, games industry, there is also the case of the arrestation of the two leaders of the Team Executor game piracy group that is known for selling methods to hack and homebrew consoles thanks to reverse engineering techniques. So you could say that history tends to repeat itself. But IP theft is just one of the many risks you have to face. As you can see on this slide, there are also data leakage risk, especially harmful since the arrival of GDPR regulation and the big fines that come along. The equivalent of DOS attack for software that can make your software unavailable, and of course the reputational damage with brand damage. You have to keep in mind that all these risks can be caused by other security breaches, not related only to code vulnerabilities. So here are some examples of search attacks that don't target vulnerabilities in the code. We have listed some type of attacks, their goals, and some examples you must have heard of. For example, the side channels attacks, whose one of its goals, but not only, is to extract cryptographic keys from application on devices. And one of the most famous example is the Spectre and Meltdown attacks that were possible because of some design flaw that were intended to make a computer and computation go faster. One of type of attacks that in all modesty we can say Quarkslab is good at is a static and dynamic analysis with reverse engineering that can achieve a lot of great results. One of the last example is the snapshot filters copied by competitors. There are also some types of attack like credential phishing, with the case of Twitter what API keys, and the last one, which is application repackaging, and that we saw for the Waze mod. By the way, one funny example of application repackaging is the one that is told in a Medium article, and that teaches how reverse engineering the Medium app and making all stories in it free. It was very funny. So now that we saw all these risks we have to deal with, the question is, what can we do to prevent this? So as you may have understood from the 30 to 40 minutes you are listening to this webinar, the best way to address those attacks is to develop a security based on different layers. It will allow, if one line of defense falls down, that everything doesn't collapse as a whole. That is a reason why I don't see Egerie, TrustInSoft, and Quarkslab solutions as competitors, but as different bricks that permit to build an efficient wall of defense. You've seen before how the two other solutions work. Now let's see how EPona, Quarkslab solution, can help you to address some of your security issues. At Quarkslab, we develop EPona with the mindset of a reverse engineer. It will be it will give you those different layers to address each kind of risk we saw previously. EPona is based on 4 pillars. The first one is a compiler that will, let's say, scramble your code by implementing some obfuscation pieces to give reverse engineering a hell of a job and try to discourage him. Obfuscation gives you an edge upon the attackers. Excuse me. It buys you time when a vulnerability is discovered to find a countermeasure to solve a security issue. And in this matter, time is often the critical point. With more than 30 different obfuscation pieces, EPona compiler is able to circumvent a lot of techniques used by seasoned reverse engineers and protect your code. One key feature of EPona is its ability to manage precisely the level of security versus the performance cost. With EPona, you'll also be able to add some runtime application self-protection in your software and have a large palette to personalize the way you want your application to behave in case of an attempt of reverse engineering technique. Moreover, EPona is a tool that was conceived with integration into CI/CD chain in mind. At Quarkslab, we are listening to our client needs and problems, and that is the reason why we make EPona evolving with key features. The two other pillars of EPona are shown here. One of these is the implementation of white box encryption that will allow you to encrypt sensitive data in a way to prevent your secrets to be stolen. For those who never heard about white box cryptography, you can see it as a way to obfuscate encryption scheme. And at last but not least, in the department of features, EPona can also propose its EPona Digital Vault that is well suited to store your sensitive data in a secure way on devices that don't embark the latest state-of-art security hardware. And even if they do, EPona will use it in order to enhance the security level. But as previously said many times, overall security doesn't rely on one single component, even if you can see that EPona is based on 4. And I'll be glad to help you if you have any concerns about your security and how Quarkslab can bring you solution. What you have to do is just write down our contact info. You can send us an email to contact@quarkslab.com or pick up your phone and call this number. Or also visit our website, quarkslab.com, to find this information. Thank you for your attention, and I will give back to Gabor.
Thank you, Thomas.
And here it is, Gabor. You're the man.
Yes. Thank you. So this basically concludes our presentation. What we would like to do now is to open the floor for a couple of questions. We are a bit behind schedule, so we might not have time to answer many questions. But by all means, please use the questions box to ask a couple of questions. In the meantime, I would like to thank you, Adrien and Thomas from Egerie and Quarkslab. I think that we were able to provide a very interesting overview of what kind of solution, what kind of complementary solutions could be put in place to protect the software during development, a little bit before and a little bit after. So as Thomas mentioned, we have our 3 solutions are not competing. We are ensuring 3 different layers of protection. And again, we are aiming towards the same goal, is to help our partners to provide software that cannot be used as an entry point for cyber attacks. So I see that everybody's very shy and I don't see any questions. if you have the contact details of the three companies, so if you have any inquiries, questions, concerns, if you need help, documentation, by all means, please contact us here, and we will do our best to help you out with your software security.
Gabor, there are actually a few questions. I don't know if you can see them.
Sorry, I can't see them. Can
No
you read
worries.
them?
Yes, so there's the first question for TrustInSoft, so for you, Gabor.
Okay.
What is the ratio between the number of tests and the number of lines of code that your analyzer typically provide?
Thank you for this question. So we are using basically the tests that are created by the developers of the source code. So if they developed tests to cover, let's say, I don't know, 80% of their code, we will ensure that those 80% of the code covered is really robust. But again, it depends on how the tests were developed by the development team. So we are relying on existing tests. We cannot extend more than what the test covers in terms of lines. However, the value that we bring to those tests is that even if those tests don't they cover only, let's say, 50% of the execution path, we can use those tests to cover all the rest by generalizing the tests. So we can be exhaustive in terms of execution paths and the values that are provided to variables in input. But again, we are quite dependent on the tests written by the development team. So I encourage developers to write as much tests as possible and to cover as much of the code as possible. It will only make our combined solutions more powerful to ensure that there is nothing left, no issues left in the source code.
Thank you, Gabor. So there is another question for TrustInSoft also from Cyril. Is the absence of undefined behaviors legally warranted to your customer? Meaning, if an undefined behavior was to be found later, do you indemnify them?
So that's a good question. The guarantee I was mentioning earlier in the presentation is a mathematical guarantee. So we will not provide any legal guarantee in terms of bugs left in the code. It's a complex question. So what we provide is a mathematical guarantee that has no legal implications no legal implications as such.
Okay, thank you. There is one last question for you, Gabor. If we use TrustInSoft, do we still need tools like Coverty, SonarQube, Checkmarks, or does it replace all other static code analysis tools?
So as I mentioned earlier, TrustInSoft is focusing on the semantics of the code, and most of the existing tools out there, they are really focusing on the syntax. It's really important to focus on those both elements of the code. It's very important to analyze the syntax. It's also very, very important to analyze the semantics. So the way that we see things is that in an ideal world, development team should use a tool like Coverity, for example, for ensuring that the code is well written. So it's important, but in the same time, we are also encouraging developers to use a tool like TrustInSoft Analyzer, because this will handle a different part of the analysis than companies such as Coverity, for example. So I would say that the best solution is to have best of the both worlds. So use a syntactic analyzer that focuses on code rules, but also use TrustInSoft Analyzer that will be able to identify issues that cannot be identified by a syntactic code analyzer. So the easy answer to this is please use both if you want to have the most robust code possible.
Thank you, Gabor. So that is all for the questions.
Okay. So in that case, thank you very much for everybody for attending this webinar, and you will hear from us in the coming days with the recording and the presentation supports. So thank you very much, and I suggest now we close the webinar, and have a very nice day.
Thank you, everybody. Have a very nice day.